Here's a GRE geometry question. Let's take a look. Each side of the square pictured above measures 6 root 3. Let me just note that right now. 6 root 3 and 6 root 3. Okay, a line is to be drawn from the black point right there to a random point on one of the sides highlighted in red. So I'll start with this sort of mind teaser question. How many lines could I possibly draw? An infinite number, right? I could draw boom, 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 boom. I could just draw them forever and ever and ever. There are an infinite number of lines I could draw from this black point to one of the red sides here. Here's the question. What is greater? The probability that the line will have a distance greater than 12 or 50%. Okay, I'm just going to say this right now. This is a tough problem. And as a starting point, let's think about this number 12 and about 6 root 3. Does 6 root 3 conjure up any rules that you might know? I hope it does. And if it doesn't, we can review them real quick. Whenever you see a root 3, you're probably dealing with special right triangles, 30, 60, 90 right triangles. Review that if you need to, right? So if I have a line that starts at this black point right here and goes to the edge of the, or rather one of the points on the red line, and that's a distance of 12, you may immediately recognize this as a 30, 60, 90 triangle because it's in the right ratios, right? This is 2x, this would be x, and this would be x root 3. So our x would be 6, right? Now, you don't even need the 30, 60, 90 triangle thing to figure this out. You can just use the Pythagorean theorem, right? 12 squared minus 6 root 3 squared, and take the square root of that. You get 6. Okay, so that's a distance of 12, right? That's a line that's a distance of 12. I could draw another line that's a distance of 12, right? Something like right there. And then, of course, this would be 6. So then we get to the probability part of this question. I'll go back to what I was saying earlier. I can draw an infinite number of lines from here to there. But if I pick a random point on this, on these red sides together, what's the probability that it's going to land outside that range? That is to say that it's going to be greater than 12, because all these lines I'm drawing right here are greater than 12, right? They're longer than these two lines. So these two lines are kind of like a border of sorts. If I go below them, right, then it's less than 12. And if I go kind of between them right here, it's greater than 12. So what's the total distance of these two lines? Well, it's 6 root 3 and 6 root 3. So that's 12 root 3. And what's the probability, or maybe the distance I could say, of landing in kind of these zones right here? Well, let me subtract out 6 and 6. Let me subtract out the parts that don't work. And I'm going to shade this in. I want to land in here. So what's that probability? Well, it's all the collection of all these points here. So that's going to be the total distance, 12 root 3 minus 12, right? Minus 6 and 6. And all the lines remaining, right, are greater than 12. Okay, well, 12 root 3, if you use your calculator, is somewhere around 20. 20 minus 12 is 8, right? 8 divided by 12 root 3, if you use your calculator for that, is in fact less than 50%. The correct answer here is B. For more GRE tips and tricks, or to sign up for my online course, follow the link on my profile.